use. Okay, the second objective, calculate the determinants by using formula. There are a few formula. Okay, number 3, find the minus and cofactor of a matrix. Okay, this one is used for the method of cofactor expansion. Okay, number 4, evaluate the determinants by using cofactor expansion method. So we will use the minor and cofactor of a matrix. Okay, number 5, find the determinants of elementary matrix. Okay, number 6, find the inverse of a matrix. Okay, by using the adjoin method. Okay, this is the application of determinant. These two learning outcome. And the last one is use the Cramer's rule to solve the system of linear equation. Okay, so there are 7 learning outcome in this chapter. Okay, first we look at what is the definition of determinant. Okay, determinant is a real number obtained by performing certain procedure on a square matrix. Okay. The characteristic of determinant must be a square matrix A. For example, we have the square matrix of A 2 by 2 or 3 by 3 matrix or 4 by 4. Okay, denote by this symbol, determinant of A. Okay, this is not a modulus. Ni determinant not a modulus. Not a modulus. Or we can use this symbol, determinant of A, det A. Okay, only a square matrix have determinant and the value can be positive, negative or 0. So there can be positive, negative or 0 determinant. Okay, determinant can be used to help us to find the inverse of a matrix. Okay, this is the application of determinant. The second one, to solve a system of linear equation. Okay, with unique solution. Okay, we learn it later in 3.3. The application of Cramer's rule and Adjoin method. This one, Cramer's rule and Adjoin method. Okay, now we look at how to evaluate the determinant of a matrix size 1 by 1. Okay, if the matrix size 1 by 1, we simply take the entry of the matrix. Okay, for example, we have this matrix 1 by 1, 6. So we simply take the entry of the matrix. So the determinant of A is 6. Okay, also, okay, B, matrix B is equal to negative 4, 2, 3. So determinant is negative 4, 2, 3. Okay, we simply take the entry of this matrix. Okay, then we look at how to evaluate the determinant of matrix size 2 by 2. Okay, we use this formula if the size of a matrix 2 by 2. Okay, we have seen this formula before in inverse of a matrix in the previous chapter, chapter 2. So determinant of A is equal to, we use the formula AD minus BC. AD A, B, C, D. So AD minus BC. Okay, look at this example. AD, then minus BC. Okay, so the determinant of A is 7. Okay, matrix B, okay, AD, so negative 8 minus 1, is equal to negative 9. Okay, this is how to evaluate the matrix size 2 by 2. Okay, we use formula AD minus BC. Okay, then how to evaluate the matrix if the size of a matrix 3 by 3 and above? Okay, we can use another method. Okay, there are 3 methods. Okay, first we can use the Saurus Rule. Okay, Saurus Rule is only applicable to a size of matrix 3 by 3. Only the size of matrix 3 by 3. Use the Saurus Rule. Okay, and then we can also use the cofactor expansion method. Cofactor expansion method. Okay, it is the best method for matrix size 3 by 3 and above. And the third method, we can also use the elementary operation. Okay, this elementary operation can be elementary row operation or elementary column operation. Row or column operation. Okay, so there are 3 methods for a matrix size 3 by 3 and above. Okay, first we look at the Saurus Rule. Okay, Saurus Rule is only applicable to find the determinant of a matrix size 3 by 3. 3 by 3 only. Okay, suppose A is a matrix size 3 by 3. Okay, first step. Okay, you have to rewrite the first 2 columns on the right hand side of a matrix. Okay, you have to rewrite the first 2 column. These 2 columns. Write it on the right hand side of this matrix. This one. Okay, and draw arrows extending along the diagonal of a matrix. Okay, first we look at how to find the S1. Okay, S1. Okay, this arrow. The main diagonal of this matrix. Okay, this is for S1. So S1 is equal to A11 times A22 times A33. Okay, plus for S1 plus the second main diagonal S1. A12 times A23 times A31. Okay, and then plus A13 times A21 times A32. So it is the summation of this one. Okay, ni boleh label kan ni lah. Okay, kita boleh. S1 is use label. Okay, label B lah. B1, B2 and B3. The addition of B1, B2 and B3. So it's equal to S1. And then S2. Okay, this is the red color. Okay, S2. Okay, ni S2. So we label C1. The product of C1, A13 times A22 times A31, okay, plus C2, the product of C2, A11 times A23 times A32, okay, plus Okay, C3. The product of this one, A12 times A21 times A33 is equal to S2. Okay, then we can find the determinant of this matrix. So it's equal to S1 minus S2. The second step, we have to find S1 and S2 lah. Then the third step, we can find the determinant S1 minus S2. Okay, look at this example. We find the determinant by using the Saurus rule. Okay, first we write the first two column on the right hand side. These two column, you write it at the right hand side of this matrix. And then we find S1. Okay, so S1, boleh highlight the pink. Okay, S1 ni 5 times 0 times 3, and then negative 3 times plus negative 3 times 2 times 2. Okay, tak boleh. Begini ni. Okay, tengok red color ni lah. Ini. So it's equal to negative 14. And the green color. Okay, 2 times 0 times 2, 0. Okay, 5 times 2 times negative 1, negative 10. Then negative 3 times 1 times 3 is negative 9. So it's equal to negative 19. Then we can find this determinant of A is equal to S1 minus S2 is equal to 5. Okay. Any question tak untuk ni? The Saurus rule. Boleh faham ya? You all mesti guna tengok pada soalan. Dia nak guna apa? Saurus rule. So we use this method lah, Saurus rule, to find the determinant. Okay, next method, the second method for the size of matrix 3 by 3 and above. Okay, we can use the cofactor expansion method. Okay, this is the second method for matrix size 3 by 3 and above. Okay, cofactor expansion. Okay, if A is a square matrix, then the minor Mij of the element Aij is the determinant of the matrix obtained by deleting the I row and j column. Okay, the cofactor is defined as the negative and positive sign of a minor. Okay, if I plus j is an even number, so it is the positive sign of a minor. The cofactor is the positive of a minor. I and j is even number. Okay, for example, we have 1 plus 1. The minor 1, 1. So the cofactor is positive sign of a minor. Okay, if I plus j is an odd number, okay, for example, we have the entries 1, 3, 1, 1, 2. Mij is 1, 2. So, okay, so 1 plus 2 is equal to 3. 3 is an odd number. Ini tadi positive. 2 kan? 2 is even. Okay, 3 is odd number. So, the cofactor 1, 1, 2 is the negative of a minor 1, 2. Okay, follow the sign pattern of this cofactor. Okay, so we have positive sign, okay, positive, negative, positive. It is alternate, in alternate form. Okay, negative, positive, negative, positive, negative, positive. If we have 4 by 4, this matrix is 3 by 3. If the matrix is 4 by 4, so we have positive, negative, positive, negative. Then positive, negative. Okay, so this one negative, positive, negative, positive. If the matrix is 4 by 4, it is alternate sign pattern. Okay, the cofactor expansion method is carried out by expanding along any row or column of a matrix. Okay, if the expansion is along the first row, okay, then we use this formula. Okay, determinant of A is equal to A11 times cofactor of 11 plus A12 times cofactor 12 plus A13 times cofactor 13. So we can choose row or any column of a matrix in order to find the determinant of A. Okay, normally we use a row or column with 0 entry. Okay, look at this example. Okay, example 1. Okay, find the determinant using cofactor expansion. Okay, first find all the minors and cofactor of a matrix. Okay, to find the minor of matrix 1, 1. Okay, we have to eliminate the first row and the first column of a matrix. M11, we have to eliminate the first row and first column. So it means eliminate all ni lah. Then we find the determinant of this matrix. Determinant. Okay, using AD minus BC. So AD minus BC. This one. So 10 minus 2 is equal to 8. So it is the minor for M11. Okay. How to find the minor for M12? Okay, the minor for M12, we have to eliminate the first row and the second column. This one. We have to eliminate this first row and second column. Then we can find the determinant of this matrix. AD minus BC. AD. So it is negative 15. Okay, minus 0. So dapat negative 15. Okay, M13, okay, we eliminate the first row and third column. So it's equal to negative 6 minus 0. It's equal to negative 6. Okay, same method lah. We use the same method to find all these minor. Okay, contoh kita tengok ni lah. Example M32. So M32 we eliminate. Okay, the third column, the third row and second column. Then we find the determinant. So negative 1 minus negative 3. So it's equal to 2. We have to find all this minor. Okay, then how to find the cofactor of this matrix. Okay, the cofactor is depend on this. Okay, if I plus j is even, so it is positive. If I and j is odd, it is negative of a minor. Okay, so kat sini C11 is, okay, C11 is positive kan. So positive times 8 is positive 8. Okay, the second M12 is negative sign. So negative times negative 15 is positive 15. Okay, ni positive 15 Okay. M13 is positive. So positive times negative 6 is negative 6. Okay, and positive, and then this one is negative. Okay, so negative times negative 2. It is positive 2. Okay, negative. Okay, this one positive. So positive times negative 5 is negative 5. Then negative, so negative times negative 2 is positive 2. Okay, this one is positive. Yes, positive times negative 2 is negative 2. And this one negative, so negative 2, positive. Positive times negative 2 is negative 2. So we have the cofactor of matrix A. Okay, ada soalan tak? Cari minor and cofactor. Boleh faham? Boleh? Okay. Okay, then how to find the determinant by using the cofactor expansion? Okay, sama tak matrix ni? Lain. Okay, we can choose, okay, for this matrix B, okay, we can choose either to expand along the first, any column or any row. Okay, this example is expanding along the first column. Yes, the first column lah. First column. Okay, normally kita akan pilih column or row with 0 entries. Yang lagi senang lah. Okay, contoh kat sini, better you all boleh pilih. Yang lagi mudah, kita boleh pilih the second column or the second row. Second column or second row sebab dia involve 0 entries kan kat sini. Kita boleh pilih second column or second row lah yang lagi mudah. Okay, tapi kat sini dia kita ikutlah soalan yang diberi kan kat sini. Okay, expanding along the first column. Okay, so kat sini lah first column. So how to solve or how to find this determinant? Okay, by using the cofactor expansion, expanding along the first column. Okay. Okay, so you all ambil lah this the entries 1, 1. So 5. First 5. Okay, times eliminate first row. First row and first column. So we get 0, 2 and negative 1, 3. Okay, and then minus. Okay, ni kenapa minus? Sebab ni follow pattern yang tadi ni positif, negatif, positif. Ada follow pattern yang tadi lah. Even and odd. I plus j lah. If I plus j is even, so it is positive. I plus j is odd, so negative sign. Okay, so untuk 1 ni, so negative sign lah. We put negative sign. Negative, so negative 1 lah. Okay, negative 1. Okay, untuk second ni, okay, you eliminate the second row lah. So we get, okay, negative 3, 2, negative 1, 3. Okay, and then plus 2, positive sign, plus 2. Okay, so eliminate the third row. So we have negative 3, 2, 0, 2. Okay, then we find this determinant. So 5 times, okay, this determinant, 0 minus negative 2 is equal to 2. Okay, minus 1. Okay, this one, negative 9 minus negative 2 is negative 7. Okay, this one, negative 6 minus 0 is negative 6. So, the determinant of B is equal to 5. Okay, the second example, okay, expanding along the second row, the determinant is also the same value, is equal to 5. Okay, the second method is expanding along the second row. So, you pilih ni lah, the second row, 1, 0, 2. Okay, so ni positif, tadi negatif kan. So, this one negative, positive, negative. Okay, that's why kat situ negative 1. Okay, times. We eliminate the first row, first column. So, we get negative 3, 2, negative 1, 3. Okay, plus 0. Okay, 0 ni tak ada lah. 0 automatic kita cancel je lah kan. Okay, 0. And then this one negative 2. Negative times 2. So, negative 2. Okay, so we eliminate the third column. So, 5, negative 3, 2, negative 1. Then we can find the determinant of this M21. So, it's equal to negative 9 minus negative 2. It's equal to negative 7. Ini 0. Okay, this one, negative 5 minus negative 6. It's equal to 1. So, the determinant of B is also equal to 5. Okay, you boleh pilih mana-mana lah. Column ataupun row. Okay, ada soalan tak untuk ni?
Tak ada, madam.
Tak ada eh? Okay, kalau guna matrix 4x4 pun cara dia sama. Sama juga. Ni contoh 3x3 lah, 4x4 nanti kita boleh tengok lah soalan tutorial ke apa kan. Okay, next is determinant of a triangular matrix. Okay, we use this theorem if the matrix is triangular matrix. Okay, if A is upper or lower triangular matrix of size n times n, then determinant of A is the product of element along the main diagonal. Okay, if A, this one is the lower triangular matrix. So, the determinant of A is equal to the product of main diagonal. Product of main diagonal. This is lower triangular. The product is equal to negative 14. We don't have to use the cofactor expansion or the Saurus rule to solve this determinant of A. We can just simply take the product of this main diagonal. Okay, also B, this matrix B is matrix 5 by 5. Okay, this is also the triangular matrix. It is the upper triangular matrix. The upper. So we can just simply take this main diagonal of this upper triangular matrix. It is equal to 96. Okay. Okay. The last method for matrix size 3 by 3 and above, okay, we can use the elementary operation method. Okay, elementary operation method, we can choose either using the elementary row operation or elementary column operation. Either row or column operation. And you have to reduce this matrix, okay, into a triangular matrix. You have to reduce this matrix into triangular matrix. Okay, so if we have found the triangular matrix, so the determinant is equal to the product of the main diagonal. Product of main diagonal. Okay, note that the changes that occur in the value of determinant when the elementary operation are used on matrix A to obtain a triangular matrix B. Okay, if we use the operation of interchanging the two rows, okay, interchange these two rows from A to B, we use Ri interchange to Rj, or we use the column interchange row or column. Okay, so the sign, we have to multiply with negative sign. Negative. Multiply with negative. Okay, the second, if we use the multiplication of a row with a constant. Okay, for example, if we want to reduce matrix A to matrix B, okay, we use, for example, 2R1 interchange with 2R1, transform into R1. So we have to multiply with 1 over K. This one, can ikut ni, 1 over K. From A to B, so we have to multiply with 1 over K times the matrix B, the determinant of matrix B. So we get 1 over 2, 1 over 2 times the determinant of matrix B. Determinant of A is equal to 1 over 2 times determinant of matrix B. Okay, if we use the operation 1 over 5 row 2 transform into row 2, so we have to multiply with 5. 5 times the determinant of matrix B. Contoh 1. Okay, the third operation, if we use this third operation, okay, adding a multiple of one row to another row. Okay, for example, we have 2 row 1 plus row 2. Okay, transform into row 2. So the sign is equal, determinant of A is equal to determinant of B. It does not change if you use this third operation. Okay, adding a multiple of one row to another row. Okay, a combination of elementary row or column operation, okay, can be used to compute the determinant. So we can combine the elementary row or elementary column operation. Okay, the triangular matrix obtained it not be in its row echelon form. And the elementary column operation, okay, cannot be used to solve the system of linear equation. It only can use to solve the determinant. Elementary column operation. Column hanya untuk determinant je. Solve the determinant. Okay, look at this example. Okay, find the determinant of matrix A. Okay, using elementary operation. Okay, we have to reduce this matrix A into the triangular matrix. Reduce into triangular matrix. Okay, first, okay, apa yang you perlu buat kat sini? Now, first you perlu tukarkan this matrix into the determinant. Determinant. So we have this symbol lah, determinant. The symbol of determinant. Okay, first apa yang you perlu tukar? Okay, kat sini. Ni dia guna interchange row 1 with row 2. Sebenarnya tak perlu interchange pun tak apa kat sini. Ini tak perlu pun tak apa Kalau kita kalau ikut dia, ni sebenarnya tak perlu pun tak apa. Kalau ikut pun boleh lah ni. So first step, interchange row 1 with row 2. Sama je kan. So 2, 4, interchange lah. So interchange involve negative sign kan. Negative sign. Sebab kat sini interchange. So interchange involve negative sign. So we put negative 1 lah. Okay, so interchange row 1 with row 2. Okay, after that, we want to make, okay, this row 1 is leading 1. So we have to use the operation 1 over 2 times row 1 to make it leading 1. Okay, if we use this operation, okay, we have to multiple with 2. Tadi kan, 2 kan. So kat sini sebab tu dia dapat 2 lah. Times with 2. Sebab dia follow tadi yang operation number 2 tadi. Kat sini. Multiple a row with a constant. So kat sini if 1 over 2, so dapat 2 lah. 2 times the determinant of B. So 1, 2, negative 1. Okay, 2, 5, 2, 0, 2, negative 2. So negative 1 ni kita bawa juga. Bawa. Okay, and then kita perlu jadikan ni 0. Negative 2 ni. So if we want to make this interchange, we make this 2 into 0. Okay, we use the operation. So negative 2 row 1 plus row 2. Transform into row 2. Okay, ni untuk third operation kan. So third operation dia tak berubah lah tadi. So dia hanya ubah row ni je lah yang kedua. So 0, 1, 4. Okay, and then nak jadikan triangular matrix. Okay, ni perlu jadikan 0. So we use operation. Okay, negative 2 row 2 plus row 3. Transform into row 3. Ini dia guna negatif. Sama lah ni. Okay, yang ni pun tak berubah lah. Dia punya sign. So ni akan dapat 0, 0, negative 10. Okay, so ni you all dah dapat dalam bentuk upper triangular matrix kan? Upper triangular matrix. Yang ni tak perlu jadikan 1 pun tak apa. Kalau nak jadikan 1 boleh juga. Ni. Kalau contoh you all nak jadikan 1 kan, pun boleh. So, tambah lagi satu operation, negative 1/10 row 3 kan. Contohlah tambahkan operation. So kat sini kena multiple with negative 10 lah kat sini. So dia akan jadi negative 1, 2, negative 10 kan. Tambah kat sini times negative 10. Kita akan dapat yang sama jugalah. 2, 0, 0, 1. Okay, so determinant of this matrix is equal to the product of main diagonal. Is equal to negative 10, the product of main diagonal. Ataupun yang ni sama. The product of main diagonal multiple with this. Negative 2, negative 1 times 2. Kat sini, you boleh dapat ni lah. Negative 1 times 2 times the product of main diagonal. 1, 1, negative 10. Ataupun kat sini, untuk yang ni, kita akan dapat negative 1 times 2 times negative 10 times main diagonal is equal to 1. Is also equal to 20. Okay, boleh yang ni?
Boleh. Boleh.
Okay, yang ni pun sama lah. Okay, yang ni dia melibatkan column operation. Dia interchange column 1 with column 2. Column 1 with column 2. So we put negative 1 lah, negative sign. Then reduce until this one is upper triangular juga, upper triangular. So the determinant is equal to negative 1 times the product of main diagonal, which is equal to negative 12. Untuk yang example tu ni ada combination lah. Combination with column operation and row operation. Combine column and row operation. Ni pun boleh
Madam.
Ya. Yeah.
Mana hilang kosong, mana hilang nombor 2 tu madam dekat soalan tu?
Di mana?
Kalau tengok dalam example tu kan bawah tu kan 0, 2, negatif 2. Mana hilang 2 tu?
Kat mana? Ni.
Dekat questions tu, dekat given that B equals to 2 to 0.
Oh, dia salah salin ni. Salah salin soalan ni.
Oh.
Salah ni, buat 0 lah ni. Salah salin soalan. Patutnya 0, 2, negative 2 kan ni. Ni salah salin soalan ni. Ni ubah lah soalan ni. Salah soalan. Ni ubah soalan ni. 0 lah. Okay, thank you. Siapa yang tanya tadi? Okay, ni contoh yang lain lah. Evaluating the determinant using elementary operation. Okay, given, okay, this matrix, determinant of this matrix is equal to negative 2. Okay, find the determinant of this new matrix. So you have to transform this new matrix. You're going to transform this new matrix into this matrix. we have to reduce lah. Reduce this matrix into this matrix. Okay, kita salin lah. A, B, C, A, C, B. Okay, kena ubah kan. So, first dia interchange column 2 with column 3. B, C. Nak interchange B and C kan kat sini, B and C. So, we use column 2 interchange with column 3. So, we put negative 1 sign kat sini. So, interchange lah row column 2 with column 3. Okay, dah interchange kat sini. Column 2 with column 3. Okay, and then second operation we use R2 plus R3 transform into R2. Okay, sebab kat sini dia nak eliminate G ni kat sini. G nak eliminate yang ni. So, sepatutnya dia guna apa? R3 plus R2 lah. Transform into R2. Okay, this operation kita tak ada ubah, ubah apa-apa kan. So, kekal je lah. Just ubah je lah operation dalam ni. So, A, B, C, G, H, I. Okay, ubah yang ni. R3 plus R2. So, R3G plus D minus G is D. H plus E minus H is E. I plus F minus I, F. Okay, so ni dah dapat yang untuk original ni. Determinant of original matrix. Okay, so determinant of this matrix is equal to negative 2. So, determinant of this matrix is equal to 2. Negative 1 times negative 2 is equal to 2. Okay, ada soalan tak? Ni. Boleh faham? Kira application sikit lah. Application untuk elementary column or row operation. Kena apply kan. Okay, next is identify the matrix with zero determinant. Okay, if determinant of A is 0, if matrix A has row or column with 0 element, kat sini 0 element, 0 column 2 0 element kan. So A is equal to, determinant of A is equal to 0. Okay, number 2, if 2 or more row or column in matrix A are identical. Dia sama. Identical. Ni dia sama kan. Row apa, column 1 sama dengan column 2. So, determinant of B is equal to 0. And number 3, a row or column in matrix A is a multiply of another row or column. Okay, example for matrix C. Okay, matrix C ni first row is 2 times first row is equal to row 3. So, determinant of C is equal to 0. Ni theorem lah. This new theorem involves zero determinant. Okay. Next theorem, determinant of elementary matrix. Okay, let E be elementary matrix and let K be scalar. Determinant of elementary matrix is based on the elementary row operation. Okay, to produce the elementary matrix. Okay, if you involve the interchanging the row. Okay, so we use negative of identity lah. So is equal to negative 1. Okay, if involve the multiplication a row with scalar. Okay, for example, we have this one. Okay, 2 row 1 interchange with row 2. Okay, then the determinant of elementary matrix is equal to this scalar. Okay, number 3, involve the third operation, adding a multiple of one row to another row. Okay, for example, this one, 2 row 1 plus row 2, they change, transform into row 2. So the determinant of E is equal to 1. Okay, look at this one. Okay, elementary 1. Okay, is equal to negative 1. Okay, because involve row 2 interchange with row 3. Row 2 interchange with row 3. So determinant is equal to negative 1. Okay, elementary 2. Okay, this involve operation 2 row 1 transform into row 2. 2 row 1 transform into row 2. So it's equal to 2. Ini sebenarnya daripada I to E lah kat sini. I to E kan. 1 0 0 0 1 0 0 0 1. So it involve 2 row 1 kan. Transform into row 1. 2 0 0 0 1 0 0 0 1. So it's equal to E2. E2 is equal to, we follow the skala lah, this skala is equal to 2. Okay, yang ni pun sama ni tadi. From identity 1 0 0 0 1 0. Nak jadikan yang ni. So R2 interchange with R3. So E1 is equal to negative 1. Okay, yang ketiga E3. We use operation apa? Untuk jadikan ni. 2 row 1 plus row 2 kan. Transform into row 2. 2 1 0 0 0 1. Okay, this operation so is equal to 1 tadi. E3. If you use this operation, so is equal to 1. So this is the theorem for elementary matrix. Okay, ada soalan? Ni just theorem lah. Kalau you all tak follow the theorem ni pun kita boleh je cari kan. Kalau ni kita dapat lah dia punya determinant ni equal to this product. Ni pun sama. Equal to this product. Is equal to 1. Untuk yang ni kena reduce lah. Reduce kepada apa dia yang ni. Jadikan ni 0. Ataupun ni kat sini kena jadikan 0 lah ni. Dan nanti you all multiply dia punya diagonal akan dapat multiply diagonal dia. Tapi ni kena reduce dulu lah untuk E1 ni. Ni just a theorem lah yang you all perlu tahu. Okay, ada soalan tak? Tak ada eh? Okay, tak ada. Kita tengok properties. Okay, property ni biasanya you all perlu proof lah. Proof left hand side equal to right hand side. Okay, ni 3.2 The property of determinant. Okay, number 1, determinant of a product of a matrix. Okay, A times the determinant of A times B is equal to determinant of A times determinant of B. Just multiply lah the determinant of A times determinant of B. Okay, given determinant of A is equal to 7, B is equal to 5. Darabkan je lah. Okay, A to power of K. Okay, K is any scalar. So determinant of A to power of 2 is equal to 7 to power of 2. 49. Okay, second property is determinant of addition of a matrix. Okay, determinant of A plus B is not equal to determinant of A plus determinant of B. Yang ni salah you all perlu tambahkan A plus B dulu. Determinant of A plus B kena add on lah A plus B, A plus B. So A plus B is equal to this one. Okay, then find the determinant. So 21 minus 3 is equal to 18. It's not equal to determinant of A plus determinant of B. Determinant of A plus B is 12. Tak sama kan? Kena tambahkan dululah. Okay, number 3, determinant of product of scalar with a matrix. Okay, K is any scalar. Okay, is equal to K to power of N times determinant of A. Okay, N is depend on the size of matrix. Size of matrix A. Okay, the size of matrix A is 2 by 2, so 6 to power of 2 is equal to 252. Okay, number 4, relationship between invertibility and determinant. Okay, square matrix is invertible if and only if determinant of A is not equal to 0. Okay, since determinant of A is equal to 7, so A is invertible. Ini nak proof untuk invertible lah. Invertible or non-singular kan? Or non-singular. Okay, number 5, determinant of inverse of a matrix. Okay, if A is invertible, okay, then the determinant of A is equal to the inverse of A. Determinant of inverse of A is equal to 1 over determinant of A. Okay, inilah 1 over determinant of A. 1 over 7. Contoh lain kalau dapat determinant of B inverse is equal to 1 over determinant of B. B is 5 kan? 5. Okay, number 6, determinant of transpose of a matrix. Okay, determinant of A transpose is equal to determinant of A. Dia sama lah. Determinant of A transpose equal to determinant of A. Yang ni pun selalu ni keluar. Okay, and then is equivalent condition. Okay, equivalent condition follow this theorem. Okay, if A is a square matrix, then it follow this condition. A is invertible. Okay, if determinant of A is not equal to 0, okay, the system of linear equation AX minus AX equal to B is consistent and has unique solution. Okay, the homogeneous system of linear equation AX equal to 0 has trivial solution. Okay, matrix A can be written as product of elementary matrix. Okay, this one is from the previous chapter, elementary matrix. Okay, matrix A has a non-zero determinant. Therefore, determinant of A is not equal to 0. Okay, it's same as number 1. Matrix A is invertible. Okay, A is row equivalent to identity matrix. Okay, this is useful theorem that summarizes the important concept in linear algebra and should be referred to when solving problems related to linear system of linear equation. Okay, ni sekali. Oh, yang 3.3 ni sekali 3.2 ni, notes ni. Sama kan ni? Ni tak ada lah ni. Okay, ada soalan tak ni untuk 3.2 ni, properties? Apa yang awak perlu ingat, nombor 1 sampai nombor 6 lah. Ada 6 property kan. Perlu tahu lah. Biasanya nak prove left hand side equal to right hand side. Ataupun you perlu ingat, contohnya property yang penting yang ni lah. Untuk determinant transpose of a matrix. Ataupun ni inverse of a matrix ni. Okay, soalan kita tengok last. Okay, application of determinant. Okay, there are two application. Okay, first to find the inverse of a matrix. Okay, using the adjoin method. Okay, adjoin method, we use this formula. We want to find the inverse of A. Okay, is equal to 1 over determinant of A times the adjoint of matrix A. Adjoint of matrix A. Second application, to find the solution of system of linear equation, okay, using Cramer's rule. Okay, so we use this formula to find the variable x, x1, so determinant of a1 over determinant of a, and so on, x2 and xn. We look at this later, this example in Cramer's rule. Okay, first we look at, okay, what is adjoint method? Okay, steps involved in finding the inverse of matrix using adjoint method. Okay, there are 3 steps. Okay, first you have to find the cofactor of a matrix. First step, find the cofactor of a matrix. We have learned before to find the determinant of cofactor expansion. Okay, this cofactor matrix. Okay, the second step, okay, transpose the cofactor matrix to get the adjoint matrix. Okay, we transpose the cofactor matrix as the cofactor transpose of matrix is equal to the adjoint matrix. And the third step, okay, find the inverse of a matrix using this formula, adjoint formula. 1 over determinant of A times the adjoint of A. Okay, look at this example. To find the inverse of A, okay, using adjoint method. Using adjoint method. Actually, we can simply find this matrix A and the inverse of matrix A. Okay, using the previous one, 1 over the AD minus BC, and AD minus BC is 3 minus negative 4. And then, sebelum ni ada belajar chapter 1. We interchange A with D. So 3, 1. Okay, then we change this sign. So 2, negative 2. Okay, 1 over 7. 3, 2, negative 2, 1. Okay, dapatnya sama lah. 3 over 7. 2 over 7. 2 over 7. 1 over 7. Okay, this is using the inverse formula. Okay, this example is using the adjoin method. So for adjoin method, we have to find the minor of this matrix A. Okay, how to find the minor? Okay, so for the minor M11, we eliminate the first row and first column. So it's equal to 3. 1, 2, we eliminate the first row and second column. So you get 2. And this minor 2, 1, we eliminate the second row and the first column. It's equal to negative 2. Minor 2, 2, we eliminate the second row and the second column. So you have 1. Then the cofactor is the positive and negative sign of a minor. Okay, so ni positive. Okay, this one negative. Negative minor. So we have negative 2. Okay, this one pun negative. So positive 2. This one is positive. So positive 1. So the cofactor of matrix, this one. Okay, and then second, find the adjoin matrix. Adjoin matrix is the transpose of cofactor matrix. Okay, transpose. Interchange row with column. So we have this one. Then apply this formula of adjoin method. Find the determinant of A is equal to 7. And then this one is the cofactor transpose of a matrix. So you have the same answer with using the inverse formula in chapter 2, previous chapter. This also apply for matrix size 3 by 3, the same method. We have to find the minor, the cofactor, and transpose the cofactor matrix. And last one, using formula of adjoin method. Okay, the second application is the Cramer's rule. Cramer's rule is used to solve the system of linear equation. Okay, look at this example. Okay, this example is to solve the system of linear equation using Cramer's rule. The previous one, we have used the elementary row operation to solve this system of linear equation. But in this chapter, we use the Cramer's rule. We apply the concept of determinant. Okay, first of all, you have to transform this system of linear equation into the matrix form. the general matrix form. This one, the matrix form. Okay, matrix A times X is equal to B. So matrix A lah, the coefficient matrix times variable matrix is equal to the constant matrix. Okay, Cramer's rule tadi apa formula? X equal to the determinant of A 1 and over of A. So Y equal to determinant of A2. Okay, first we have to find the determinant of A. So determinant of A yang ni lah. Matrix, determinant of matrix A. Is equal to 3 minus negative 4. Is equal to 7. Okay. Then, if you want to find the value for X, so we have to find the determinant of A1. Okay, A1 ni sebenarnya AX lah. AX. Okay, AX, we interchange the first column, okay, with the constant matrix. Kita ubah kat sini. So the first column interchange with the constant matrix 4, negative 1. The second column remain the same lah, negative 2, 3. Okay, and then we find the determinant of A1. 12 minus 2 is equal to 10. Okay, therefore, the variable X can be obtained by applying this method, this formula, Cramer's rule. So determinant of A1 is 10 over determinant of A, 10 over 7. So X equal to 10 over 7. Okay, if you want to find the value for Y, so value for Y, so we change this second column. This second column. Okay, blue color ni. With the constant matrix. 4, negative 1. So this first column remain the same, 1, 2. So we find this determinant, so negative 1 times 8 is equal to negative 9. So variable Y is equal to negative 9 over 7. We can check this value lah for X and Y. Substitute into this equation. So the answer is correct for both value X and Y. Okay, ada soalan tak? So this is the last example for chapter 3, Cramer's rule. Okay, summary for this chapter. Okay, matrix which are not the square matrix do not have determinant. So only a square matrix have determinant. Okay, determinant is a unique real number. Okay, it can be positive or negative value or zero value. Okay, there are 3 methods of evaluating the determinant of matrix size 3 by 3. Okay, we can use the formula. Okay, formula, we call it Saurus Rule. Saurus Rule, this formula. Okay, second method, we can use the cofactor expansion. And the third one, we can use the elementary matrix, either column or row operation. Column or row operation. Okay, elementary column operation can be performed in finding the determinants. Okay, however, it cannot be used in solving the system of linear equation. So the elementary column operation is only for finding the determinant. Okay, kat sini ada ramai yang silap kadang-kadang you all nak solve the system of linear equation, you all gunakan column operation. Yang tu salah Column operation hanya untuk determinant je. Ini. Ramai yang tersilap lah kat situ. Untuk linear system of linear equation hanya gunakan elementary row operation, row je. Okay, the last one, the value of determinant can be applied in finding the inverse of a matrix. Okay, inverse of a matrix, we call it the adjoin method. And also in solving a system of linear equation. Okay, we use the Cramer's rule. This Cramer's rule. There are two applications for determinant. Okay, this reference is from our textbook.